Hi, my name is Devin Levine, and I'm honored to be presenting here at the Geodesign Summit 2021. I want to thank both Ryan and Daniel for the opportunity and everyone else at Esri. Um, the talk I'm going to be giving is called Evaluating Development Proposals with 3D GIS. And again, my name is Devin Levine. I'm a principal and co-founder of a planning firm called Houseal Lavigne Associates. My special expertise is in 3D GIS, CityEngine, um, and applying emerging technologies to the field of city planning. And our company, we're based in Chicago, Illinois, and Pasadena, California. We work all over. We work at a ton of different scales. And something that we say is we love to innovate. We love to have fun. And I'm particularly excited about this project, and I hope you enjoy it. So we are working with the community of Glen Ellyn, Illinois, on their comprehensive plan. And Glen Ellyn is about 20 miles west of Chicago, and they've hired us to help them craft their long-range vision for their community. And in undertaking this planning process, seven-step planning process that involved a really robust engagement despite COVID. We've gone through, we've given them a snapshot and existing conditions analysis, that long range vision. We've prepared a sub-area plan for downtown, which is the focus of this talk, as well as the plan, all of the village-wide components, and then finally adoption. And just want to highlight one of the tools that we use to help us reach out during the area COVID. It's a tool called map.social. And what it allowed us to do is have a conversation with the community over top of a map. So in the time of social distancing and getting people together to have a workshop, map.social allowed us to launch a portal where everyone in the community can put pins in a map, tie a note to it, and we're able to pull all the comments together to see what they said. So we collected 102 points of interest from this community. You can see that giant cluster right in the middle. Downtown is a focal point of Glen Ellyn. It is an area of concern, an area of where they want to see things change, like they want to redevelop this site. There's an old fire station. They want to see it redeveloped. There's a problematic intersection with poor sight lines. We heard from people. There's so a lot of different ways people commented through this application, as well as surveys and outreach. And as we went through the plan, downtown took on a real strong focal point. The vision statement even highlights the need for downtown to be small, to be compact, but to have increased residential density and a mix of stores and expansion. The land use plan itself, the community character we know was front and center. There's policies on it, maintaining that small town atmosphere and character. But the downtown, the focal point, this red area on the land use map, was identified as mixed use. And the plan even states that higher density mixed use development can complement the existing architecture downtown and should be encouraged. And so Glen Ellyn is a lot like other small, vibrant, compact Midwest downtowns. It has transit service into the city of Chicago, but you can see in these images wide sidewalks, real active storefronts, historic buildings, historic architecture, smaller in scale, but the community desired more. They wanted to see vibrant and mixed-use development. And so despite the community signaling through the outreach and through the plan that they wanted redevelopment in their downtown, development proposals were met with resistance by the community, concerns over height. And by height, I don't mean 5 stories or 6 stories. I mean 47 feet versus 48 feet. Density, how many dwelling units per acre had become a challenge. The style, the architecture, the materials, the colors, and the parking location. Every development brought forward, despite having supportive staff, knowing that it would contribute positively to downtown and move downtown in a direction consistent with the long-range vision, it was met by opposition at Plan Commission and their village board. And so these plans, the typical watercolor, pencil crayon site plans and elevations weren't cutting it. As nice as these looked when they got to that phase, they were getting getting denied. And so the village had seen this project we did for the town of Morrisville, North Carolina, where we helped using the CityEngine and Unreal Engine. We helped this community determine if a less dense option or a more dense option for their town center was more appropriate. And we're proud this plan won a special achievement in GIS last year. And ultimately, thanks to this tool, they chose the more dense option, this 3 to 4 story option for their town center. Now, Glen Ellyn is a little different. It's an existing historic downtown, a lot of architecture, a lot of character. This wasn't Morrisville where we had a greenfield. So what we had to do with Glen Ellyn, we had to take a different approach. We had to model the existing downtown. And then we were going to put development proposals into it to see how they fit. So using ArcGIS Pro, we took building footprints, and then we brought in LiDAR information. And then using the Esri local government solution for 3D base maps, we extracted information like the roof forms, the building heights, and we passed that information into GIS. We also used the published trees where we classified trees in LiDAR. We extracted the points of trees. We knew the heights. And so we're able to get these 3D symbolic trees in GIS, and we took all that information, we brought it into CityEngine. And inside of CityEngine, we're able to write rules that are able to read that GIS information. So the LiDAR told us how tall buildings were, they told us what the roof forms were, they told us where the trees were. And so inside of CityEngine, we took all that information and we constructed a 3D model. This served as the foundation for our contextual model. It's just a simple massing model. This initial run was strictly a pilot project for this site, the Avere on Duane. And so we brought that into CityEngine. We located it in the right spot using CityEngine's manual drawing tools. We traced in the development. And then using CityEngine's powerful procedural modeling, we just dropped in our rules and created a 3D model of what the Avere on Duane would look like. So here we can quickly turn just a simple red mass into a more detailed building, and we can change other attributes like the height. So this was for a pilot project. They wanted to kind of have us test out to see if this would work for their community. So we took this development. We took all these 3D models, and straight from CityEngine, we published it into the Unreal gaming engine. And inside Unreal, we built a user interface, and we gave them a character. And so this is me in Unreal, and I'm walking around the downtown. And we added the library. We call that a hero building, a little more detailed. And then here is this development that was being proposed. And here's that 25-story building. What we did get was a building from the architect. And so we dropped it in. And we showed their village board. We had a live meeting where we streamed the video from our computer, and we showed them, this is what's being proposed. And that's what's across the street, and approved the development. They were thrilled. Unanimous approval for the Avere, and what they told us was they wanted to see the rest of downtown in 3D. The challenge for us was the next site that we knew was coming forward for development had some terrain issues and topography. And so we needed to build grade into here. And I don't know if you caught that in that last model, but it was perfectly flat, and it's a lot easier to do. So what we had to do was build in terrain. So using 1-foot contours from the community, we used topo to raster inside of ArcGIS Pro. We turned that into a height map, and we brought that height map into CityEngine, and we replaced the elevation height map that comes from the Esri elevation service with something a little more hyper-local with the 1-foot contour, and we brought that into CityEngine. And then we draped all of those shapes, all of our building footprints, our roads, our sidewalks, the parking lots. We draped them on top of our height map. We draped everything except the buildings. Those we just projected to the lowest height, and you can see they kind of stick up there. And to fill those gaps, we write rules that extrude buildings up and also extrude them down. And so that helps kind of make sure there's no gaps. So what we're doing is kind of building a foundation for the building, retaining walls. It really creates an airtight environment. And so version 2, this is the development that wanted to take advantage of the grade. You can see as I'm walking here, there's a little bit of a hill. And so there was a development that wanted to come into this vacant parking lot. And this is what they wanted to do. And so this was version 2. And we also gave them the ability to take a picture. It saves it into their camera roll. And you'll notice, though, we had some weird things happening with our CityEngine geometry. We're getting this kind of rippling. What we realized was that CityEngine doesn't give us the full control we needed over the shapes. And so inside of CityEngine, we did a couple things. We created a little rule here that adds resolution. And when we run it, it tessellates out and it starts chopping up our geometry. And you can see the effect of that over these hills is it draped much more cleanly on top of our height map. And so when we took that and we projected it down, we also split up the road quite a bit. And we applied those rules to the entire downtown. And so the third version of this, so we also added cars. I'm kind of standing on one, getting a closer look. You can see how precise we're able to be with the topography, where we're seeing the dips in the sidewalks, where there's a curb depression. And then we also were able to bring the road to the gutters and then put seams down the middle of the streets, kind of how roads are constructed. So just an excellent example, I think, of how now this community is using this tool to evaluate development. So if a development gets proposed, we drop it in, we give them the game file. They're able to walk through and see, do they like the character? Do they think it's going to contribute positively to their downtown? They're able to go across the street into their commuter lot and can look at the existing condition and look at what's being proposed and make a real informed decision. And then again, taking pictures, building it in their staff reports. And so this one, this development is called the McChesney site. Unanimous approval by Village Board. We heard from the planning director. They were expecting just a really long meeting, a real drawn out opposition. She called us the next day. Meeting went smooth, super fast, unanimous approval. Could not believe it. So in a typical planning process, you prepare plans, developer prepares plans, they run it by staff. Staff can give them feedback, and but ultimately that developer's proposal will go to Plan Commission. Plan Commission can take public input. They could also ask the developer for revisions. But then at some point they'll recommend either onto the village board or city council, whatever the elected body is, that they either want to approve or deny the proposal. And then finally, city council or the elected body will make a determination whether they want to approve or reject the proposal. Again, also providing an opportunity for public input as well as revisions by the developer. What this community has done, what Glen Ellyn has done, is altered this a bit. Developers prepare their plans, but they also submit a 3D model. We then take those models, we use ArcGIS Pro, CityEngine, and SketchUp, and we prepare them into the immersive 3D experience. And so we get them into Unreal, we publish out an application, we give that to staff. Staff is able to share it with Plan Commission, with City Council. They're able to really scrutinize and explore the development, look at the building setbacks, the building heights, the architectural character, views from adjacent properties, what's it look like from the public realm, and make a much more informed decision. And one of the drawbacks is it's a game file. It requires basically a gaming computer, something with a dedicated graphics card, ideally. And so that is a drawback with this technology. It does require a little bit of a robust system. But we've been working with a company called PureWeb. And before I wrap up, I'm going to hand it over to Mark Francis Cangeli from PureWeb. And we've been working with them on a solution to distribute this in the cloud and have some additional supporting information, some of the other maps from the plan, really not just help us get the application out there to everyone on any device, but also to extend the application with GIS information. So I'm going to pass it over to Mark. So thank you again for the opportunity. If you have any questions, please reach out to me. You can get a hold of me at hlplanning.com. And with that, Mark, you can take it away.
Thank you, Devin, and hello, everyone. Devin, that was a great example of how GIS and game file technology is aiding in geodesign. Imagine, if you will, having the ability to take it one step further by bringing more data from Glen Ellyn into the visualization tool, bringing data that helps city councils make better decisions, or better yet, helps cities engage with its citizenry in a collaborative environment for public consultation. Let's explore this a little bit more. There's a growing opportunity in all of this. And if there was ever a perfect storm for digital twins or smart city applications, it's now. Technology is offering all of the ingredients needed to understand projects without having to be in the field or on site. The first piece is IoT standards have greatly improved and are more affordable. This allows a municipality to censor a multitude of assets in surrounding environments. We are seeing the convergence of GIS and game engine providers and bringing the ability for that integration. The third thing is game engines for enterprise is an incredible tool for visualizations. Again, I think Devin did a great job of that with some of the artistic flair that he put into the game file that he showed earlier. And now, cloud streaming these large files is easily accomplished, giving access to anyone on any device, virtually anywhere in the world. So I do want to introduce PureWeb's agent platform for digital twin and smart city solutions. And if we start talking about what is the agent platform and what does it represent, well, it represents a common operational picture that allows stakeholders to understand in unison the status of projects in real time. What I'm going to do now is I'm going to take you to the agent platform itself. And what I'm about to show you is, in fact, the game file that Devin and Houseal Lavigne created. And we've brought it into the agent platform and connected it to GIS data. Okay, I would like to point out to everybody that we are now in Agent Platform. I'm going to go ahead and open a few applications. I'm going to come down and open up the Community Facilities map. We'll start there. I am also going to open up the Glen Ellyn game file. I will go ahead and click on that. The next thing I want to do is invite my friend and colleague, Kevin Viggers.
Hey, Mark. Coming in on video.
Perfect. How are you today, Kevin?
I'm fine. How are you?
Good. I'm also going to share, or at least launch my camera so that you can all see me as well. Kevin, do you mind, since you're the creator of the platform and the brains behind the operation, do you maybe mind showing us some of the functionality and the integration between the GIS data and the game file?
For sure. If we look at the game view here, you can see I'm moving around here and interacting with the game. Worth note is that this game is running in the cloud in the PureWeb platform and it's streaming in real time to the browser here. And the browser user can be anywhere in the world, so they can pick up and interact and have a conversation and collaborate around this virtual world from virtually anywhere. I'm moving the player, and you can see on the map, if you take a quick look around, there's a dot indicating the position of the player in that virtual world. So, Mark, do you want to pick up that dot and move me to that development that the model talks about?
Yeah, absolutely. Let me grab that. Sorry. Yeah. There we go. And I'm going to drop that right there. It should be about where that new development is. You can see now I was able to participate, grab the dot and drop it in a location. And now our player in the game is dropping into that spot. Now I should, if we spin him around, I will take control of that. I'm going to find where we are. And sure enough, Kevin, there is the proposed development that Glen Ellyn was looking at. And I can again now participate in that. I can take the existing conditions. I can also show the proposed conditions. So that was a great example of collaboration and integration between GIS data and game file data. I do want to point out that we're not limited to just that. Again, agents can be just about anything. Examples of agents that we often see come into things like this is IoT feeds. We see LiDAR come in. We see CAD and BIM files also participate in this. And again, when brought into the agent platform, they very much recognize each other's values without really understanding that they're each in the platform itself. Mm-hmm. So Kevin, thank you for participating. I'm going to kill my camera if you want to kill yours.
All right. Have a great presentation, Mark. We'll talk to you soon.
Thank you. And I am actually going to stop sharing now and head back to the presentation. So again, if we consider what we were just looking at here, the enhanced performance for Glen Ellyn in the application itself or in the platform itself, you're going to be able to see things like monitoring. A digital twin merges live data from its physical counterpart and its interactive visual interface. This offers an unsurpassed level of monitoring. If we consider maintenance, the improved monitoring that we just spoke about, so the improved monitoring capabilities mentioned, feed directly into the maintenance efficiencies. Again, the simulation, digital twin is an excellent tool for mirroring real life scenarios with call it a no consequence outcome. The proposed multifamily development in Glen Ellyn is a great example of that. We can give people the experience of what it's going to look like in very real form before we even break ground. The fourth thing is communication. A digital twin can play a vital part in helping City Council share knowledge with its citizenry. And then the fifth thing is strategy. And a digital twin solution can be extremely useful in testing new concepts for optimizing without needing to disrupt the daily life of your citizens. Think of road work as the example for that, or planning road work. You can literally do it within the game file before you even put boots onto the street. Distribution is a very important piece of this solution work. Ensuring that everyone can access the content is extremely important. Eliminating the need for specialty hardware, whether for citizens or council, is key, and we have achieved this with the digital twin solution. We do this by making the content available on light devices. So when we think of tablets, phones, smartphones, PCs, etc., we can dynamically scale content based on user demand, allowing for peak periods of usage and lulls to be managed effectively. The ability to run multiple 3D streams from a single cloud instance ensures that everyone has their own unique experience. And keeping content secure with no downloads or plugins is very important. No one ever has access to the source code of the twin. That concludes our discussions for today. I want to thank Houseal Lavigne for allowing us to collaborate on this project and encourage you to reach out to me with any questions. Thank you.